Welcome to our channel. Today, we're diving into the mind-bending world of quantum mechanics. Get ready to be amazed by some of its most shocking features. You know, when most people think about quantum mechanics, they picture a blackboard covered in complex equations, right? But that's not what excites me. See, beneath the math, quantum mechanics tells a story about the universe that's stranger, weirder, and more wonderful than practically anything you could dream up. We're talking about a reality where particles can be in two places at once, where information travels faster than light, where the very act of observing something changes the outcome. It's enough to make your head spin, but trust me, by the end of this video, you'll be hooked. Let's talk about quantum superposition. Imagine you have a single particle, like an electron. In the quantum world, that electron can be in multiple places simultaneously. Until we measure it, the electron exists in a fuzzy state of probability. It's like it's both here and there, all at the same time. The moment we measure the electron's position, the superposition collapses. And boom, it appears in one specific location. Quantum superposition is the foundation for mind-blowing technologies. Quantum computers aim to harness superposition for incredible calculations. Now, if you thought quantum superposition was weird, buckle up because it's time to talk about quantum entanglement. This phenomenon is so bizarre that even Einstein called it spooky action at a distance. Imagine you have two particles that are entangled. This means they're connected in a way that transcends space and time. When you measure the state of one particle, you instantly know the state of the other particle, no matter how far apart they are. It's like having two coins flipped at the same time, even if one coin is on Earth and the other is on Mars. If one lands on heads, you instantly know the other one landed on tails. Now you might be thinking, okay, maybe there's some invisible signal traveling between the particles, but here's the thing. The information transfer between entangled particles seems to happen instantaneously, faster than the speed of light. This violates our classical understanding of how information should travel. It's like the universe has found a shortcut, a loophole in the fabric of space-time. Quantum entanglement is one of the most profound mysteries in modern physics. It has the potential to revolutionize computing, communication, and even our understanding of the very nature of reality itself. Chapter 3. Wave-particle duality. Is it a wave? Is it a particle? It's both. Okay, get ready for another mind-bender wave-particle duality. This is the idea that quantum objects, like electrons and photons, can exhibit properties of both waves and particles. Think about light, for example. We know light behaves like a wave. It diffracts through narrow slits and interferes with itself, creating those beautiful interference patterns. But light also behaves like a particle. When it hits a solar panel, it interacts as discrete packets of energy called photons. So, which is it? Wave or particle? Well, that's the thing. It's both. It depends on how we choose to observe it. If we set up an experiment to measure wave-like properties, light will act like a wave. If we set up an experiment to measure particle-like properties, light will act like a particle. It's like light has a split personality, and it's constantly messing with us, making us question the very nature of reality. Wave-particle duality isn't just a quirk of light. It applies to all quantum objects. Electrons, protons, even entire atoms can exhibit this bizarre behavior. Chapter 4. Quantum tunneling. Through walls like a ghost. Alright, let's talk about another mind-blowing phenomenon, quantum tunneling. Imagine you're throwing a tennis ball at a wall. In the classical world, that ball is going to bounce right back at you, right? But in the quantum world, there's a chance that ball could actually tunnel right through the wall. It's like the particle borrows energy from the universe, momentarily violates the conservation of energy, and pops out on the other side. Now, the probability of a macroscopic object like a tennis ball tunneling through a wall is astronomically small. But for tiny particles like electrons, quantum tunneling is a regular occurrence. In fact, without quantum tunneling, the sun wouldn't even shine. The intense pressure and heat in the sun's core are necessary to overcome the electrostatic repulsion between protons, allowing them to fuse together and release energy. Quantum tunneling is also essential for many modern technologies, including transistors, flash memory, and even some types of medical imaging. Chapter 5. Heisenberg. Uncertainty principle. You can't know everything at once. One of the most profound concepts in quantum mechanics is the Heisenberg uncertainty principle. Named after physicist Werner Heisenberg, it states that certain pairs of physical properties can't be known with perfect accuracy simultaneously. The classic example is the position and momentum of a particle. The more precisely we measure a particle's position, the less we know about its momentum. It's a fundamental limit imposed by the universe. This principle has profound implications for our understanding of the universe. The quantum adventure continues. Thanks for watching. If you enjoyed this deep dive into quantum mechanics, don't forget to like, share, and subscribe for more mind-blowing content. We've only scratched the surface of this incredible field, and there's so much more to explore. From the mysteries of quantum consciousness to the possibilities of quantum computing, the future of quantum mechanics is bright. So, keep those questions coming, keep your minds open, and never stop exploring the universe. Because as we've seen today, the quantum realm is full of surprises. Please subscribe to our channel for more mind-blowing facts about quantum mechanics.